Hey guys, here is Unit 3 on the triangle inequality theorem. I know we've looked at inequalities in triangles. There is a triangle inequality theorem, and I wanted to first take a look at three different sizes. I got a 3 centimeter piece, I got a 4 centimeter line, and I got an 8 centimeter line. And could I make a triangle with these three? That's the challenge. So if I was to take my, let's say my 8 centimeter one, let's take my 3 centimeter one and move it a little here and there. Put it on here. Let's take my 4 centimeter piece. Put this on here. Okay, maybe I need to bring them closer together. Maybe it's a bigger obtuse triangle. And so let's see if that would work. Still too short. Let's see if I even brought it down closer. Still too short. So the answer to that question then is definitely a resounding no. You cannot make a triangle with sides that are those three sizes, a 3, a 4, and an 8. So why can't I? That's the key question. I thought any three sides I could make a triangle. Well, that's not true. They have to be certain sizes to be able to make the triangle, and the triangle inequality theorem is what helps us. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. That means if I was to add 3 plus 4, that means 3 plus 4 must be greater than 8. And since that is not in this case, therefore it is not a triangle, or it is not able to be made into a triangle. So that's your triangle inequality theorem. So let's look at the perpendicular postulate. They throw this in here, a little side note here. Given a line and a point not on the line, just like our parallel postulate. Remember, a postulate is a statement we don't have to prove. It's a given statement that we can always use. Given a line and a point not on the line like we have here, there is exactly one line that can be drawn that contains the point and is perpendicular to this line. There's only one line that I could put in here that would be like this. That would make it perpendicular. That would also go through this point. You know, if that's 90 degrees, and I was to change this line at all, if I was to move this at all, it's not going to be perpendicular anymore, and it may not even go through the point. So there's only one line that I could draw in that's perpendicular to this line, and it goes through that point. Alright, here's some key practice problems. Which of the following side lengths form a triangle? Let's see, 5, 7, and 8, could that be a triangle? Let's check it out. 5 plus 7. 5. Take my smallest two sides. 5 plus 7. Is that greater than 8? Oops. Is that greater than 8? And the answer is yes. 5 plus 7 is 12, and 12 is greater than 8. So 12 is greater than 8. It is a triangle. What about this one? Take my smallest two sides, 3 plus 5. You don't have to go in order. I don't have to do 3 plus 9 first, just because 3 and 9 are listed first. I can take my smallest two sides, 3 plus 5, and that has to be greater than 9. In this case, your answer is a resounding no. 3 plus 5 is 8. 8 not greater than 9. So that would be not a triangle. So A could be made into a triangle, B could not. So here's a key little factoid for you. To find the possible lengths of the third side of a triangle, given two sides, you can add and subtract the two sides that you have. So to find the possible lengths of the third side, that means I've given two sides already, you can add and subtract those, and you would find the possible values that could be the third side. So let's look at this right here. Find the possible length of the third side of a triangle that has sides 6 and 11. So if I have a 6 and an 11, let's actually draw a 6 and an 11. Let's say this is my 6, and then 11 is going to be almost twice as much. So there's my 6 and 11. Actually, yeah, that's fine. All right, so let's take those two. Let's put them together as a triangle. So if I was going to put this, I really want to extend it. I just want to move it. So let's do this. Let's just turn it and bring it over here. Let's say we bring it over here like this. Okay, so there's a 6, there's an 11. What are the possible lengths of this third side? Well, if I was to take this third side and bring it as close to this as possible, and I was to have this being 6, and this one being 11, you could see that the third side here is going to be basically 11 minus the 6 to see what's left over. So possibilities are 11 minus 6, which would equal 5. Now it can't actually equal 5, because if the third side is a 5, that means the 6 and the 5 are laying directly on top of 11, and that would not be a triangle. It needs to be just at least a little touch more than 5. 11 minus 6, if I was to subtract them, it would equal 5. Now, if I was to make this side right here come way over here like this, and I was to make it come almost to where it's a line, almost. This is my 6 over here, this is my 11 right up here. Actually, put the 6 underneath. If I was to connect this side with this side way over here, you might see that it's almost 6 plus 11. So you almost have 11 plus 6. But your triangle couldn't be greater than 17. If it's greater than 17, then it's going to be too long for these two sides. And it can't be less than 5, otherwise it won't stretch and reach. Because remember, 6 and 5 has to be more than 11. So my third side has to be somewhere between 5 and 11, 17. It has to be greater than 5, because otherwise they won't reach, they won't touch. The 6 and the 5 won't touch to the 11. And it has to be less than 17, because if it's more than 17, it'll extend way past these two. So the third side has to be somewhere in the middle of these two. It cannot be anywhere outside of those. It can't be less than 5, and it can't be more than 17. So let's apply that to this problem right here. The problem says, it's a U-try, so you should try it. You should pause it and try yourself. The sides of a triangular sail measure 6 feet and 8 feet. Stop looking at the challenge problem down here. You can do that one later. Do this one first. You can figure the challenge one out in a little while. What are the possible lengths of the third side of the sail? So a sail has a 6 and an 8 sides of a triangle. So if I'm going to find the possible lengths, I mean, it might be a really small acute triangle where I would need to do 8 minus 6. That would equal 2. Or it might be a really, really huge obtuse triangle where I'd have to do 8 plus 6. And that would be 14. So that's somewhere in between these two. you look at these two right here, our third side has to be somewhere in between these two numbers. So we would write that as an inequality. We would say 2 is less than x is less than 14. And all that tells us is that this x, this third side, has to be somewhere in the middle of those two numbers. It's got to be greater than 2, it's got to be less than 14. Alright, that is it for the notes. Now you can look at the challenge problem, see if you can figure out how many triangles are in that. And the first answer wins. So, good luck, and we'll see you guys later.